So we can use quadratics in application problems, and so today we're going to do some geometry ones. Area is a square unit, so quadratic equations absolutely are used to solve problems involving area. So in these, my suggestion is to draw a picture and then we'll write the equations and go from there. So we'll do some of these together. Number one, the length of a rectangle is 7 meters more than the width. So first thing we're going to do is draw a rectangle. So we'll say the length is 7 more than the width, so we'll say this is the width. The length is the width plus 7, because it's 7 more than the width. The area is 60 square meters, so I know to find the area of a rectangle, I have to do area equals length times width, or base times height is what your formula chart says. It actually is not good that I did the times like that, but I just wanted to show you. So, you know the area is 60, so we're going to fill that in. We know the length is W plus 7. We know the width is just W. So now we have that. I'm going to zoom in, make it a little bit easier to see. So now I need to rewrite this where I distribute this W through. And this, in the past, the way you've seen this is the W in front like this. So these two are exactly the same. I just rearranged it where this W is in front instead of behind, and I can move it like that because this is multiplication. And so it'd be the same as if I did 2 times 3 or 3 times 2. It doesn't matter which one goes in front because it's multiplication, so the order doesn't really matter. So it's the same in this scenario. So now I'm going to distribute. So I get 60 equals W times W is W squared. W times 7 is 7W. So now that I have that distributed, I can rearrange this to look like quadratic by moving this 60, because remember we always like it in the ax squared plus bx plus c equals 0. So in order to get it in that format, I need to move this 60. So to move this 60 to the other side, I'm going to subtract it from both sides. So I would get w squared plus 7w minus 60 equals 0. So now that I have that in the standard form, I can choose to solve it by different methods. So I could use factoring. I could use a table by type it into your calculator. I could graph it and see where it intersects. So since it's not easy for me to show you the calculator on here, I'm going to solve by factoring. So I need to decide what can make 60. So my factors of 60, and it's actually a negative 60. So, and I need them to add together to be positive 7. So I could do negative 6, positive 10, positive 10, negative 6. I could do 12 and negative 5. I could do negative 12, positive 5. I could do 20 and, sorry, I've lost my pen, 20 and negative 3. I could do negative 20 and positive 3. There's several more I could do, but again, remember I'm trying to get it to add to be positive 7, so I know this first one won't work, second one won't work, but this one, positive 12 and negative 5, absolutely will make a positive 7. So these are the two factors that I'm going to use, so it would be w plus 12, w minus 5. However, if you wanted to do w minus 5 and then w plus 12, remember it doesn't really matter which order these go in, but this positive has to be with the 12 and the negative with the 5 in order to make the positive 7 later. So now that equals 0. So now to actually solve, I would do w plus 12 equals 0 or w minus 5 equals 0. So then I solve by subtracting 12 from both sides, so I get w equals negative 12. And this one I would solve by adding 5 to both sides, so w equals 5. So at this point, my answer would be that the width is either -12 or 5. So in the past, we would just write our answer like that with the brackets, and we'd be all done. So the difference with today versus in the past is this is an actual application problem. So I have to think about the original question. So the original question is we're finding the length and the width. So is there any way I could have a width that's -12 on a square or a rectangle? Absolutely not. So it just doesn't make sense to have a negative length. So this is where, since we're using application, then the -12 is not going to be an answer for us because it doesn't make sense in this problem, in this application. So our answers would be the width is 5. So if I know the width, I can find the length because it said that the length was the width plus 7. So it'd be 5 plus 7. So the length is +12. So don't get it confused. The fact that this is +12 is kind of just it had to do with the original question and had nothing to do with the fact that this was -12. It just worked out to be 12. But just understand that this is where you have to kind of stop and use your brain, go back to the original question and see if it works in the application. Next one. A picture frame, which most picture frames I've seen are rectangles or squares. So it says the picture frame is 18 inches by 14 inches. So I'm just going ahead and drawing my picture. If 221 square inches of the picture shows, find the width of the frame assuming the distance is equal all the way around. So this time you have to think about when you have a picture frame, it actually has like two rectangles together. So this outside edge we know is like made out of wood or plastic or whatever the picture frame's made out of. So the actual picture frame distance that we're talking about, it told us 18 by 14, that's the outside edge. But the picture inside, we know that we couldn't put a picture in there that's 18 by 14 because part of it would be blocked off by this outside. So it says if 221 square inches of the picture shows, find the width of the frame, assuming the distance is all the same all the way around. So we need to know what this distance is. We don't know it, so we're going to use that as x. So that distance, and that distance right there would also be x because we know it's the same all the way around even though my picture does not look like that. So I know this inside area is 221 square inches because it tells us that in our problem. So now I need to know the length and width of that inside area. So I know this, we'll say the length right here, would be 18 minus, so I know instead of, I'll zoom in and show you, instead of it being the whole 18 inches, it's 18 inches, take away this amount and this top amount. And we called this amount x and this amount x. So it would be 18 minus 2x. So we'll say that's the length. The width is 14 minus, because we again have to take off. So we have this whole way across is 14, but we need to take off this amount and this amount. So this would be 1x and this would be 1x. So we're going to take away 2x. So the width would be 14 minus 2x. So then I know the area. So I'm going to set up my problem. So area equals length times width. So it'd be 221 equals my length. I'm just going to replace with this. So in parentheses I'll do 18 minus 2x. And my width is 14 minus 2x. So now I need to solve this. So in order to solve, I have to distribute these. So this is two binomials multiplying together, so I'm going to use FOIL. So 18 times 14, and then outside, inside, last. So let me just back up a little bit. So I would do my first times my first, so 18 times 14 is 252. Then I would do 18 times negative 2x is going to be negative 36x. Then I'm going to do my inside right here, negative 2x times 14, which is going to be negative 28x. And then last times last. Negative 2x times negative 2x is positive 4x squared. All of that is equal to 221. So now I'm just going to rearrange the right hand side of this equation to be in the order you're used to seeing it. So we'll put this first. So 4x squared, that's positive. I can combine these like terms. So negative 36x and negative 28x, when I combine those, I'm going to get negative 64x. Then I just have this positive 252, and that's going to be equal to 221 still. So again, in order to get into the standard form, I need to move this 221 to the other side so that it'd be equal to 0, so that way I can solve my quadratic. So I'm going to subtract 221 from both sides. And so I'm going to get 4x squared minus 64x plus, whenever I subtract this, I get 31. And that's equal to 0. So now I can choose to factor, I can choose to graph, I can choose whichever way I want. So last time I chose factor, so let's try a different way this time, and I'll just have to walk you through the calculator. So on your calculator, first thing, always make sure your calculator is cleared. Then we are going to go to, I'll try to write the steps out, we'll go to y equals. And we're going to type in 4x squared minus 64x plus 31. Then, let's do it. Okay, so I typed this in. So that's in y1. Now let's go to y2, and we're going to type in 0. So the other side of the equal sign is 0. So we typed in this side to the y1 and this side to y2. Now before I keep going, I need to look at some of these numbers, because I know if I graph this right now, this is not going to show up on the graph, because I know that I have like 31 here, negative 64 here, I have some pretty big numbers. So before I push graph, and it still might not even show up like how we're going to do it, but first we need to change our window. So in our calculator, we're going to go to window, and then in window, let's do our x-min. I'm going to go negative 100 and do positive 100 and count by tens. So my x-max and then my scale. Then the same for my y. I'm going to use negative 100, 100, and 10. And we'll just try and see how that looks. If you push graph at this point, so now we're going to push graph, you're going to see, so here's kind of what my calculator looks like. It looks weird, and it kind of looks like there's just a line going this way, but it's actually coming up next to the axis as well. So I can see at least where my zeros would be, because remember my zeros are where it crosses, and that's what I'm looking for my answers are my zeros. So here was your first step, your second step. I like to look at the graph before I keep going. My fourth step, sorry this is really awkwardly placed, but my fourth step is going to be to go to calc. So remember calc, you do second trace button, that's how you get calc. And when you go to calc, go to number 2, which is 0. So when you type in number 2, you on your graph are going to get like a little, it looks like a little X with a little circle thing in the middle on part of your graph. So when mine first shows up, it's like over here somewhere on the side. And the question says left bound. So you want your little I'm going to call this a spider. You want this little spider to be on the left side of the zero, of this left side of the parabola. So mine right now has the spider right here. I'll draw it in blue. And so I'm going to click enter to say yes, this is my left bound. After I push enter, then the question says right bound. Well, I can't leave the spider in the same place because that's not right bound, so I need my spider to be to the right of where it crosses. So I'm going to use my arrow key, my right arrow key, until my spider shows up kind of below. So my spider showed up down here, and that is to the right of this first intersection. So then I'm going to push enter, and then your calculator says guess, and you push enter. And so then at the very bottom it says 0, and it has x equals 0.5, y equals 0. So this is one answer, the 0.5. Okay. Then I need to go back and do the same thing again. So I'm going to go number 2, or go to calc, number 2, 0. So calc, number 2. And now my spider showed up kind of the same place I put it the first time. Well, I want to know the second answer over here. So I need the left bound to be somewhere here, because it's going to be to the left of the second 0, or the second intersection point. So I have to use my right arrow key to get it. I'm going to put it back like down here where I put it, and I'm going to hit enter as yes, this is my left bound now. So in this section, my spider is my left bound. Now I need my spider to be somewhere up here for my right bound. So I'm going to use my arrow key and just scoot over. I don't know, I'm going to click it a few times. And you'll notice that you're going to get this like arrow this way, and then an arrow this way. So it's going to be like your left bound and right bound, because you want to know what's the 0 in between those two spots. So then it's going to say guess, you're going to say enter, and then the answer for that one, it says 0, x equals 15.5, y equals 0. So this is your other answer. So just like with most quadratics, we ended up with 2 answers. Okay, so we did a lot of work, and we got 2 answers, and so you're used to getting 2 answers, and you're used to saying, oh, and my brackets, which that's a horrible one, I got 0.5 and 15.5, so that's my final answer. But remember, this is an application problem, so we have to see which one of those answers makes sense. So does it make sense that the frame around the picture frame would be 0.5 or 15.5? Well, it makes absolutely no sense for the frame to be 15.5 inches, because the entire distance of the across the bottom is 14, so there's no way that that small frame around it, the amount of space around it, would be 15.5, because it's bigger than 14. So I know 15.5 is not going to be an answer in this application. So I know that it says the width of the frame. The width of the frame has to be 0.5 inches, because it's the only one of the answers that makes sense. Okay, so on the next page, you have 3 questions that you're going to try on your own. Make sure that you draw a picture, and some of these are going to have more than one picture. Please remember, this one has to do with a triangle, and the area of a triangle is 1/2 base times height. Don't forget this 1/2. You know how to find the area of a square. That's the second one you have to do, or number 4 right here, you have to do area of a square. Number 5, perimeter of a rectangle. If you know the perimeter, you know that all the sides added up is 36. You need to figure out how to do the area. So remember, to do perimeter, you could do 2 times the length plus the width. That's how you could find the perimeter. but the area is length times width. So just know that and draw a picture, and that'll help you out. Alright, good luck.